Hi guys, in today's lesson, I'll be answering some Jamb likely related questions on radioactivity with us. If you have not watched my previous video on radioactivity, I want you guys to watch those my previous videos. So let's commence with today's lesson. And the first question says, in the nuclear reaction given below, which is this, it says the particle S represent. Now if you look at this very well, this is the particle that is represented with what? With S. So the question says in the nuclear reaction given below, which is this reaction, the question says the particle S represent. Now if you look at this very well, and this reaction simply represent what? A nuclear reaction. In one of my previous teaching on radioactivity, which is on my YouTube channel, I talked about what? Nuclear reaction. If you guys have not watched that video, I want you guys to watch that's my previous video. Now I'll be answering this Jamb question with what? With us. Now in solving nuclear equation like this, what we do is that we'll solve for the mass number up first, then we'll now solve for what? For the atomic number down. So that's what we do. Because the question says the particle S, which is this S, represents what? We don't know yet because they gave us option. Option A is what? Alpha, a beta particle. Option B says a neutron particle. Option C says an alpha particle. Option D says a proton. So we don't know which one of them. So until we get our answer. And like I said earlier on, we are going to solve for the mass number first, then before solving for what? For the atomic number. Now this is how to solve questions like this or nuclear equations what like this. So this is how to represent it. So we say what? 238, which happens to be the mass number of the parent nucleus. So it was 238 equal to this mass number of this element thorium, which is what? 234 plus. Now this, we don't know the element here, or we don't know the particle here rather. And because we don't know the particle here, we don't also know the mass number of the particle, and we don't also know what? The atomic number of what? Of the particle. Now, since we don't know the mass number of the particle, we call it A to find what? The mass number. So it's not be what? It's not be what? A plus what? Plus A. Now, at this point, you collect what? Collect like terms. So what will happen is that we'll move this 234 across the what? Equality sign. And please take note that when positive number is crossing equality sign, it will change to what? Negative number. Or when negative number is crossing equality sign, it will change to what? Positive number. Also take note of what? Of this. So it will not be what? 238 minus, because this is a positive number, crossing equality sign, it's not be what? Minus 234 equal to what? A is not remaining, equal to A. Now, so therefore, our A equal to, now 238 minus 234. 238 minus 234 is what? Is 4. So therefore, our A is what? Is 4. So take note that our A, which happens to be the mass number of this particle that you have not known, is what? Is 4. Now let's do the same for what? For the atomic number. So it's now be 92 equal to 90 plus Z. This Z is representing what? The atomic number of what? Of this particle. So please take note of what? Of this. So it now be what? Collect like terms. So it now be what? 92 minus 90, because 90 is crossing equality sign, equal to what? Z. Therefore our Z equal to what? Now 92 minus 90 is what? 2. So therefore our Z is now what? Is 2. Now under radioactivity, which particle has charge of what? Of 2 and mass number of what? Of 4. Of course, is the what? Is the alpha particle, also known as what? The helium nucleus. Is it that have what? A charge of 2 and a mass number of what? Of 4. And the helium nucleus looks like this. So it looks like what? It looks like this. Please take note that alpha particles, they are actually what? A helium nucleus. So you should please take note of that is what? An alpha particle. And if you go to the option A says what? A beta particle. Option B says what? A neutron particle. Option C says what? An alpha particle. Now we already gotten our answer, so no need to ever go to what? Option D. So option C is the answer. An alpha what? Particle. Please take note that an alpha particle is usually be represented like this is actually what? A helium nucleus. They have what? Mass number of 4 and a charge of what? Of 2. So you please take note of what? Take note of this. So this is the answer to what? To this particular question. So if you don't know how to solve nuclear equation before, this is a way to what? To solve nuclear equations to what? Like this. So please take note of this. So moving on, we'll be moving on to what? To the next practice question, which happens to be what? Question 2 of today's lesson. And now the question says, which of the following radiation has the highest ionizing power? I come again. The question says what? Which of the following radiations has the highest ionizing power? Option A says alpha particle. Option B says beta particle. Option C says gamma rays. Option D says X rays. Now, all this question just talking about the particle, the particular particle that has what? The highest ionizing power. And under radioactivity, under types of radiation, we have two major types of radiation. We have the major radiation and the minor radiation. So please take note of this, that we have what? The major radiation and the minor radiation. And please take note that under the major radiation, we have the alpha particle. Please take note that under the major radiation, we have what? The alpha particle or alpha ray. We have the beta particle or beta ray. And then we have what? The gamma rays. So you should please take note of this. Now, let's talk about some of the characteristics of the alpha particle. Now, one of the characteristics of the alpha particle is that alpha particle have the highest ionizing power. So, among the three types of major radiation, the alpha ray or alpha particle, they have what? The highest ionizing power. So you should please take note of this. And now the question is saying that which of the following radiation has the highest ionizing power? And when I was talking about characteristics of the alpha particle or the alpha ray, I said that one of the characteristics of the alpha ray or the alpha particle is that they have the highest ionizing power. So please take note of this. Now, another characteristic of the alpha ray or particle, because you can call them what? Ray or particle. So another characteristic of the alpha ray or particle is that they have the lowest penetrating ability among the three types of what? Major radiation. But we're not talking about penetrating ability right now. We have the major focus for this question is what? Ionizing power. So in terms of ionizing power, the alpha particle or the alpha ray, they have what? The highest ionizing power. So if you look at the option very well, option A says what? Alpha particle, and option A happens to be what? The answer. Now, since you have gotten the right answer for this question, it means that option B, option C, and option D, they are what? They are wrong. So option A, which happens to be alpha particle, is what? The correct answer. So option A is what? Our correct answer for this practice question. Please, if you find this class very interesting, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. Don't forget to like my video. Don't forget to what? To share my video, and don't forget to what? To comment to my video. So let's continue with what? With today's lesson. So the third question says, which of the following is used as a moderator in a nuclear reactor? And option A says boron rod, option B says graphite, option C says uranium-235, option D says what? Lead shielding. Now, if you look at this question very well, the answer to this question is option B, which is graphite. Please take note that graphite is used as what? As a moderator in a nuclear reactor. So please take note of this, that graphite, which is option B, is used as what? As a moderator. It's used as what? As a moderator in what? In a nuclear reactor. Please take note that it is not only graphite that is used. Please take note that deuterium can also be used. Deuterium. So please take note that deuterium, which is what? Which is an isotope of hydrogen. Which is an isotope of hydrogen. So it can be said like this. Deuterium H21. So deuterium can also be what? Can also be used as what? As a moderator in what? In a nuclear reactor. So please take note of this. But for this particular question, graphite is what? Is the answer. So please take note of what? Take note of this. So for this particular word, for this particular Jamb question. So let's move to the fourth question. Now the fourth question says the time taken from 1/2 of the atom of what? Of a radioactive substance to decay is called what? Now, if you look at the option very well, the option A says decay constant, option B says mean life, option C says half-life, option D says activity period. And the question says that the time taken for one half of the atom of what? Of a radioactive substance to decay is called what? Is called what? The half-life. So please take note that among the option, the answer is what? Half-life for this what? Particular question. And now, what is half-life? The half-life of a radioactive element is the time taken for half of the total number of atoms in a given sample of what? Of the element to what? To decay. So one half of that of the given sample of a particular element to decay is what we refer to as what? As half-life. So the option here is what? That means the answer to the option, or the rather the answer to this particular question is what? Option C. So option C happens to be what? The answer to what? To this particular question. I've talked about half-life in one of my previous videos on radioactivity, which is currently on my YouTube channel. Watch that video if you have not watched it before to gain more idea on what? On half-life. A radioactive element has a half-life of what? Of 4 days. What fraction of the original sample remains after 12 days? Now, if you look at it very well, the question says what? A radioactive element has a half-life of what? Of 4 days. So the half-life given was what? 4 days. And the question is say what fraction of the original sample remains after 12 days? So they're asking us to find what? The fraction remains that is remaining after what? After 12 days. Which means if they're telling us to find the fraction remaining, which means there was a fraction of the particular sample that was lost, or that was decayed rather, under radioactivity. So we use the word decay. That was decay what? Rather under what? Under radioactivity. Now they are telling us what? To calculate the fraction left, not what? The fraction that was decayed, or the general fraction of the sample of the what? Of the particular radioactive element. But rather they're telling us what? To calculate the fraction that what? That is left, which is what? The fraction left. Now, in course of today's lesson, I'll be showing us an important formula for calculating fraction left. So please take note of what? Of this formula. And the formula is, take note of this formula, fraction left is equals to what? Open bracket 1/2, close the bracket, raised power what? Raised power n. So this formula you can calculate what? Fraction left. And in this particular question, they are telling us what? To calculate fraction left. Where n is this formula, please take note that n is this formula. N is equals to what? T naught over what? T half. So please take note that n in this formula is what? T naught over what? Over T half. Where T naught is known as what? Giving time. So T naught here is known as what? Giving time. So T naught is known as what? Giving time. Where T half here is known as what? T half is known as what? Half-life. So please take note that this T half is known as what? As the what? As the half-life. So you should please take note of this. Now, having brought out this, now let's go back to the question to bring out what? Our parameters. Now, the question says a radioactive element has a half-life of what? Of 4 days. So the half-life is equal to what? 4 days. The half-life is what? Is 4 days. And then it says what fraction of what? Of the original sample remains after what? After 12 days. Now these 12 days happen to be what? Our given time. So please take note the given time, which happens to be the T naught also, is for the 12 days. So T naught is equal to what? 12 days. So our T naught is equal to what? 12 days. Now having brought out this, we need to calculate for what? For our n first before calculating for what? For the fraction left. So n is equal to what? T naught over what? T half, which happens to be the half-life. So T naught is what? 12 over our T half, which happens to be the half-life, is what? Is 4. So 12 divided by 4 is what? Is 3. So our n happens to be what? Happens to be 3. Now I haven't got to the n, which is 3. Now let's now impute it in the formula to get what? To get our fraction left. So therefore, please take note that fraction left is equal to what? 1/2 raised power n. So equal to what? 1/2 in bracket. N is what? Is 3 that we got before. So equal to what? 1/2. Now please take note, what I want to do here is that if you look at this 3 is outside the bracket. Now, say the 3 is outside the bracket is both for what the 1 and both for what the 2. So the 3 is for both the numerator and both the denominator. So what I will do now, I will use the 3 to what? To open the bracket. So that's what I want to do here right now. So now because what? 1 raised by what? 3 and 2 raised by what? 3. Now, 1 raised by 3 is set as saying 1 times 1 times 1. And 1 times 1 times 1 is equal to what? It's equal to 1. So equal to 1. 1 raised by 3 is equal to what? Equal to 1. Same thing happens with the denominator. 2 times 2 times 2. So 2 raised by 3 is as in 2 times 2 times 2. And 2 times 2 is what? 4. 4 times 2 is what? 8. So because what? 1 over what? 8. So our fraction left is what? 1 over 8. So this is the answer that we got. Now, of course, we will give you option. Option A says 1 over 4. Option B says 1 over 8. Option C says 1 over 16. Option D says 1 over 2. And of course, option B is the correct answer, 1 over 8. And then we got what? 1 over 8. So option B is what? The correct answer. So option B was correct answer to what? To this particular question. So please take note of what? Of this formula for calculating what? Fraction left. So let's move to the next practice question. The next question says a sample of 80 grams of a radioactive isotope decays to what? To 5 grams in 20 days. Calculate the half-life of the isotope. Now, if you look at this question very well, you'll be seeing mass because we have 80 grams here, we have 5 grams here, and gram is a unit for mass. Now, if you look at this question very well, this question is talking about mass. Though the actual question says that calculate the half-life, but you are seeing gram in what? In this particular question. Now, I'll be showing us a formula for calculating question related to what? To mass under radioactivity. And the formula is, please take note of what? Of this formula. So solution. Please take note of this formula. The formula is Mi over Mf is equal to what? 2 whole number raised by what? Raised by n, where n is equal to what? T naught over what? T half. So please take note of this formula. So with this formula, you can calculate what? Masses. So you can calculate question regarding to what? To masses under what? Under radioactivity. Now, please take note that in this formula, Mi is equal to what? Initial mass. Mi is what? Initial mass. Then take note that Mf is equal to what? Final mass. So please take note of this. Then please take note that T naught is equal to what? Give it time. Give it time. So please take note of this. While our T half is equal to what? Our T half is equal to what? Half-life. So please take note of this. Half-life. So please take note that in the formula, in this particular formula, our Mi is what? Initial mass. Mf is what? Final mass. The T naught is known as give it time, while the T half is known as what? Half-life. Known as what? Half-life. So please what? Take note of what? Of this. Now, have we brought out this out? Now let's now bring out what? Our parameter. Initial mass happens to be the first mass we see in the question, while final mass happens to be the second mass or the last mass we see after the initial mass. So please take note of this. Now the question says a sample of 80 grams. 80 grams happens to be what? The first mass, which is our initial mass. So Mi, which is this Mi, is equal to what? 80 what? 80 grams. So what? Please take note of this. Of a radioactive isotope decay to what? To 5 grams. Now, so our final mass is now what? Equal to what? 5 grams. So please what? Take note of this. In what? In 20 days. In what? 20 days. Now, please take note that our T naught, which happens to be the given time, is what? 20 days. Because the given time is what? In 20 days. Because the question says a sample of 80 grams of a radioactive isotope decay to what? To 5 days. So the sample was 80 grams before, but it now decayed to what? To 5 days. In what? In 20 days. To 5 grams in what? In 20 days. So this 20 days happens to be what? Our given time, which is the T naught. So because what? Our T naught equals to what? 20 what? Days. So please take note of what? Of this. Now the question says calculate the half-life, which is this T half. So we are calculating what? The half-life of what? Of this particular what? Of this particular question. Now, using the formula, so what we are going to do now is to impute our values in what? In the formula. So our initial mass happens to be what? 80. Or our final mass, which happens to be what? 5, equal to what? 2 whole number. Now, 2 whole number raised to n, where n is what? N is what? T naught over what? T half. Now, our T naught is given time, which is what? 20. 20 over what? Our half-life, which we are looking for, which is what? T half. So this is the first step to impute what? The values into what? Into the formulas. Now, 80 divided by 5. 80 divided by 5. Please take that 80 divided by 5 is what? 16. So 16 equal to 2 whole number raised by what? 20 over what? Over T half. So please what? Take note of what? Of this. So now because what? 16 equals to what? 2 whole number raised by what? 20 over what? Over our half life. Now what we are going to do here is that now we are going to make this 16 to be like what? This 2 whole number raised by 20 over what? Over half life. Now what we are going to do is that this we are going to have base here also. So now and the two base must be what? The same for what? For the both side. Now 2 raised by what will give us 16. 2 raised by what? 4 will give us what? 16. So please take note of what? Of this. So this 16 will now become what? 2 raised by what? 2 raised by 4. 2 raised by 4 is set as saying 2 times 2 times 2 times 2. In what? 4 places. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is what? 16. How you see it now? So it's 18. 2 raised by 4 set as what? 16. So equal to what? 2 raised by what? 20 over what? Half life. Now, when the two bases are the same, they strike out. So 2 here cancel what? 2 here. So that's what happens. Now from here, it's not be what? 4 equal to what? 20 over what? Half life. So that's what will happen here. Now from here, we now what? Cross multiply. So 4 here times our half life, then equal to what? 20. So now because 4 times half life, equal what? 4 times what? Times our half life equal to what? 20. We're not looking for 4 times half life. We're only looking for what? Half life. So at this point, we are going to divide by the coefficient of what? Of this half life, which happens to be 4. So I'm going to divide both sides. So over 4 over 4. So 4 down here, cancel 4 here. So therefore, our half life is equal to what? 20 over what? Over 4. Now 20 divided by 4 is equal to what? It's equal to 5. So our half life is what? 5 days. Don't forget. Please take note that the unit of half-life and the unit of given time, which happens to be T naught, must be what? Must be the same. So please take note of this. Now, say the unit of given time is days. It also means that the unit of what? Of half-life must also be what? In days. So take note of what? Of this. So therefore, our half-life is what? 5 days. So this is what we got as our answer. Now, moving back to the option. Option A says 4 days. Option B says 5 days. Option C says 10 days. Option D says what? 2 days. And of course, we got 5 days. And option B is what? The answer, 5 days. So option B happens to be what? The correct answer. Please, if you find this class very interesting, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. So with this, we have come to the end of today's lesson. But I dropped this answer for us as a practice question for those of us that are watching my video right now to what? To practice on what? On the calculation that I just solved just now. So practice this question. I drop the answer on the comment section. Bye and see you in my next post.